Hello and good evening, everyone. Thank you for joining us on a Friday evening for Going Cloud Native with AWS. I'm Faz, and with me I have Omar. We have been running this series along with two other folks, Labib and Manasir, since July. Some of you may have joined us from before and would have seen that we have been covering a lot of topics which are kind of, you would call it like building blocks of the cloud. Basic concept which if you understand now, then it makes it easier for you to then slowly grasp all the bigger concepts on the cloud and also build applications on the cloud. So we covered a lot of topics. We covered cloud infrastructure, we did networking, storage, databases, and security. And from the security session onwards, we started inviting guests who we saw as folks who are experts in their field, and they want to share how they think of a certain topic. So we started bringing in guests. So we had Ped from Photobook, who's the CTO of Photobook, to speak on security. And last week, if you had joined us, we had Thiru, who's a partner solutions architect at AWS, to speak on DevOps. And continuing in that tradition, which has now become the norm, we have another guest today who's going to be speaking on containers. So we have Osama, and I've known Osama for almost like 2 years right now. And he is a final year student at UM, University Malayu, and he has been, he's in the computer science, IT, you call it whatever degree you want right now. What was the buzzword? And he is also an ex-DevOps engineer from Vase, and he was instrumental in building a lot of the CI/CD pipelines, in automating the infrastructure, automating the Kubernetes clusters. So someone who has that background and who has worked in the trenches, and definitely, I mean, topic like containers and even DevOps for that matter fits someone like Osama to speak on. So without further ado, here we have Osama. Yo.
Hello. Yes. Hello everyone. Thanks for having me here today. Should
Cool.
I start my slides now?
Yeah, just give me a sec. I just wanted to quickly finish this off. So just to add on over here, a lot of this program is brought by AWS DevX, and DevX Connect is a initiative we've been running from AWS, where we have experts, solution architects, specialist architects who come on board and talk about a lot of topics. So something what Osama is going to be covering today, if you want to have a more advanced version of it, you want to get more hands-on and try to understand how it works, you can just visit our DevX Connect channel on Twitch. We have a lot of videos, content being added every week. So here's the link that's available, and you can definitely just change the slider on YouTube and go back to this link if you need to. But yeah, this is useful. Idea to couple this with what Osama's doing is because Osama's been running sessions on containers and DevOps for quite some time. He's also active in the CNCF space, in the Cloud Native Compute Foundation space, where you'll see him talking soon on more topics. So yeah, I'm taking you over there in public in front of everyone on that.
Yeah.
So with that, yeah. So on to you, Osama. So I'll add you and add the screen, and yep.
Okay.
Go
Can
ahead.
you see my slides now?
Yep, totally.
Okay. Cool. So yeah. Hello everyone. My name is Osama, as Faz introduced me, and today I'm going to talk about containers. But me just show the slide that will introduce me again. I'm finally a student at University of Malaya. I study software engineering, and I did my full-time internship at Vase as a SRE. And before that, I was working as a full-stack engineer at Vase as well. Currently, I'm learning about distributed systems and gRPC because I'm interested in contributing to the cloud native projects. For example, when I was working at Vase, I used Kubernetes a lot and S2 and Let's Encrypt. So in my free time right now, I'm spending my time onto learning how to contribute to this projects. So today I'm going to talk about containers. But actually, when you mention containers, you can know that containers is a very huge topic, and it's very hard to cover it in a very short amount of time. So the best way to learn containers in practical way is to actually go and try to do it yourself and follow, for example, like tutorials, or like maybe read books about containers, or you do any things that hands-on so you can understand the whole concepts better. Okay, so for today, I thought it will be much better to give an overview, an overall overview about how containers work and how they are related to industry currently, and how we use them on a daily basis when it goes to the like production stuff and this kind of like environments. So for the first thing, we will just like talk about containers in a nutshell. What are containers? How they solve problems? Why we use them? And later we will mention if you are like, if you like to use containers, if you decided to use containers, then you need to understand two things, which is the basic stuff on like container runtimes. What are the container runtimes? What are the available container runtimes currently? And what are the history behind that? And the simplest one of this is like of this topics is the container registries, how we store containers, how we share them, how we ship them. Then I will show like a very small demo that will explain the whole things in one image. Then I will mention the Kubernetes, because Kubernetes is very important topic when it comes to containers, especially in cloud native world, because in cloud native world, they treat Kubernetes as the operating system behind cloud native projects or like solutions. And then I will show just like a small demo about Kubernetes as well. Okay, so to start, everything like related to containers or anything, it will always start with a software that needs to be deployed, right? So for example, any kind of software. So here we have like maybe a software that we call it X service or anything that you built in maybe in your classroom or like in your company and you want to deploy it. Okay, so it might be a very simple service that interacts with a database, or like a very simple hello world application, or maybe a web application, or even a very complicated e-commerce application that's combined out of multiple services. Like for example, here in e-commerce application, we have like the cart service, we have inventory service, we have the web service, the UI service. So this software needs to be deployed, right? So the older traditional way, we used to bring up servers and configure those servers. We install like operating system on that server. We configure that operating system. We put, for example, if our software needs some libraries, some configuration files, we need to make sure that those libraries are working well in that operating system, and it will not like break when we put our source code and try to run it. This is the traditional way, but this causes a lot of issues, especially when it comes to huge projects and, for example, like the company workloads and stuff like that. It causes a lot of issues because multiple libraries will clash with different versions. So, for example, if there is a library that maybe it's not compatible with your OS, or maybe there is a different version from what you used to build with your own source code. So this will cause a lot of issues that usually brought up some things that called the matrix from hell. The matrix from hell is like incompatible versions of different libraries or software that you need on your operating system, so the software will run fine with that. Okay. So containers came to existence to solve this kind of issues by a very simple thing or simple concept in theory, which is if we are going to configure our OS to run our services, and this will cause tons of problems because of the different versions, why we don't just like bring up something like a box and put our service inside that box, and whatever it needs, dependencies, libraries, or configuration files, we just put everything in that box, and that box in itself is isolated, and it will be able to run our software just fine without any interference. Okay, so this is the container in theory. It's just like a box or a wrapper that has the service or the source code of our software, and whatever that source code needs to run, and that's it. This is the container. This is the container image. Okay. So for a bigger kind of software, we might divide it into multiple smaller services. So for example, our e-commerce application, we might divide it into smaller services. This is called like from monolith to microservices architecture. but this is another topic, so we are not covering it here. Okay, so and for each service we just like do containerization for that service, and this will produce like multiple containers. Okay, each container of those containers has its own dependencies, its own configuration file, and it's ready to run on any environment because it doesn't care anymore about the OS. It doesn't care about if the OS has libraries or not because it has its own stuff on that container image or in that box. Okay. Also, like, why we care about containers, why we should use containers other than that. So with that concept in our mind, we can see that it will solve a lot of issues. The first one is we can deploy it easily. Rather than going configuring your service, you can just like bring up the thing that will run that container, which is called container runtime. We just like install it on our server, and immediately we can run the software. It doesn't matter where to run it. If you are just like run it on your production server, you can do that. If you want to share the software to your friend, you can do that. You can do that as well. It doesn't matter. So you can deploy your software anywhere on any environment, extremely easily, extremely simplified way. Also, with that, it simplifies the operation process. This will give a lot of time for developers to focus on writing their software and not care too much about configuring that software and give that to maybe the sysadmin engineer that handles the operation of that software. They don't care anymore. They just like write the software, and somehow in the background the process, there is automated process. In the background, sorry, there is an automated process that will create that container image and will ship it to the production. This simplify everything related to production. Also, like with containers, we can control the isolation of our containers. We can limit how much CPU and how much memory, how much storage and networking usage for each one of our containers. If you came from like understanding what is a virtual machine, you might think like, okay, then what is the difference between a virtual machine and a container? The shortest answer for that is virtual machines are extremely heavy compared to containers, because virtual machines, they virtualize the hardware itself as well. But containers, they just like they only have what the software inside it needs to run, and that's it. No heavy stuff. This is the shortest answer when you compare containers to virtual machines. Okay, so let's say like, okay, you agreed that you want to use containers right now and you just like want to start using it. Before that, you need to understand like two things, which is the container runtimes and the container registries. The container runtimes in its idea is very simple. It's the software that we use to run those containers. We have any amount of containers and we need something that will enable us to run or for example, build or ship our containers. This is the container runtime. Okay? And the history about that is very simple. In 2002, I believe, there was something called kernel namespaces in Linux system. So in the kernel namespaces allowed us to use, the kernel namespaces allowed us to isolate the processes into namespaces. Okay, so this makes us control what the process can see. Okay, so if there is one namespace and we run a process into that namespace, or two process into that namespace, they only can see what's inside that namespaces. Okay, then fast forward in time, we had something called control groups in Linux as well in 2007, I believe. Okay, and control groups allowed us to determine how much computing power that processes can use. Okay, so kernel namespaces allowed us to control what the process can see, and the control groups allowed us to control what the process can use. Okay, then in 2011, the first standalone container runtime was something called Linux containers. And fast forward, there was a lot of things in the industry, something called Open Container Initiative. and that changed a lot of things, and it produced multiple container runtimes. One of those famous ones is something called Rocket, and Docker. Docker is currently the de facto runtime for containers. It's hugely used in like majority of the companies. It has like very huge community around it, and it's the de facto in the standard in the industry. Okay, in 2017 or 2016, there was something came from the Kubernetes community, or the community that runs Kubernetes, which is called Container Runtime Interface. This happened in Kubernetes, but we are not going to discuss it like in depth. But it's something that we need to mention, and we will show later in the Kubernetes section how Kubernetes uses it. Okay. So for the container registries are like maybe you can think of it as a database on the cloud. Okay, where you store and your container images. Okay, so for example, MongoDB. I want to use MongoDB, the database. Okay, and rather than going to the site and try to install the database on my machine, I just like go to any container registry. The Docker Hub, for example, is the de facto as well. So I go to the Docker Hub and check up the container image for the MongoDB, and I can just like build that image and deploy it on my machine. And this will happen in just like in less than maybe 2 minutes or 3 minutes, and you will have MongoDB up and running on your machine. Okay, so Docker is the de facto runtime, and it, as I said, like it allows us to build the container images. It allows us to ship it to Docker Hub, or like store it in Docker Hub, so anyone can directly build that image and run it on their machines. And it allows us to run containers and control them in a more like in-depth way. Okay, so let me show you how all of this fit in one image. So here we have like a very simple Hello World application, which is written in JavaScript. Okay, we have this in directory called containers demo. Okay, we don't care about K8s right now.
Yeah, Osama, just zoom into that screen. It's kind of small.
Okay.
The browser. I'm sorry, the editor. Yeah.
Can you see
better,
it?
thanks.
Okay, and this
Thanks.
one. Okay. Okay, so we have a very simple Node JavaScript application here, and to generate an image, we need to write a recipe for that. We need to tell Docker that this is the steps you need to do in order to create our container image. The steps you can understand it whenever you just like read the documentation about it, but I'm going to like scan through it very fast. So for example, to run our JavaScript application, we need a runtime, right? And for that, we use the word from, and this will tell Docker that use that runtime, which is Node version 12. Okay, and this one will create a directory inside our container image, or like our box. Okay, and it will move whatever the package JSON inside our current working directory here into the image as well. So we are trying to put the source code and whatever the source code needs inside that box. Okay, then do something, run the npm install, so it can install the modules we need, the node modules we need. Okay, then expose this port, then run that command to run our source code, the server. Okay, this is a Docker ignore it, just like git ignore those files or ignore those directories. Okay, and now I'm inside the working directory. You can see it. It's the same working directory, and to generate the image, I just simply write Docker build, and I will give it a tag name, which is I will call it like my Docker Hub username, and then I will tag it with our hello server name. Okay, and check that the source code for that image inside this directory. Then when I click enter, it will go through the steps. You can see it here. Step one from 7, which is the we can find it in the Docker file. It goes through the steps, and at the end it will produce the image, the container image. Okay, so now we have the container image. It's there somewhere. Okay, so to find it, we just like run this command docker images. Okay, but I have multiple images, so I'm gonna highlight our hello server. Okay, you can see it here. So it's created 18 seconds ago. Okay, now we can run that image. We can just like run docker. If we let me try to open, like for example, if I yeah, it's running in 8080, right? Okay, so currently there is nothing on 8080. Oh, okay, and we can run we can run the image using this our hello server. Then I need to expose the port to be port forwarding from that image to my local machine. So I'm gonna say like port 8080 to my port 8080 and run it in the detach mode or like the background mode. Okay, and this when I ping it will reply to me that the server is running, despite that I'm not actually running it on my machine. I'm just running it as a container. Okay, so now let's say like I want to share this image. I want to share this image that we generated right now. Okay, so what can I do? I just like I have my Docker Hub. I have my Docker Hub account, and it has the same username as the one that I just tagged the image with it. So I'm gonna say git docker push to that username and with that server, sorry, that tag, and I just like click enter. Then this you just like push it to Docker Hub. Okay, let me try to open Docker Hub quickly. So this is my Docker Hub account, and if I go to repositories here, there is no repositories so far. So if I went to, yeah, it's still like pushing it to Docker Hub. Okay, so it should exist in Docker Hub right now. Okay, so now it exists. So this allows us to just like, if someone wants to run our application, they just like go immediately and execute the same command as us. So for example, docker run, and they can do this. They can immediately run this code, and it will pull up. Let me try to delete the image. Docker. Okay, I will delete the image. So I need to stop the container first. Docker ps. Oh, you can see. So I will just try to stop the container. I think. Okay, so the container is now stopped, and I will delete the image. Oh. Okay, I deleted the image. Okay, and now let's say like now I don't have the images the image anymore. Okay, so let's say that this is my friend's machine. He just like can directly do the run command and execute it, and it will Docker will realize that this image is not, that doesn't exist on his machine, and it will pull it from the container registry, and it will run it just like as we did, and we can kill it, and it will works. This is the power of Docker, okay, of the containers. And yeah, so when we understand Docker or containers, we need to mention as well Kubernetes, because we are talking about cloud native, and Kubernetes is considered the operating system of the cloud native. And the concept behind Kubernetes is like relatively simple. So Kubernetes is a project that allow us to run huge amount of containerized application or containers in a clustered environment. So this is like multiple worker nodes or like multiple machines, and we will install Kubernetes on top of those machines, and this will allow us to run containers, but in more like with more powerful control. Okay, so for example, in Kubernetes, you can control what will happen if your container failed, or if your container failed, Kubernetes will make sure that your service is up and running again. It will make it healthy again. It will restart it. There is a lot of things that happens with Kubernetes, and we use Kubernetes because like multiple things or multiple characteristics. The first one is, as I said, it's durable. If the service failed, it will make sure that the service is up and running again. Okay. And the second thing is, there are a lot of people that trying to use Kubernetes because they don't want to be vendor locked. Okay. So for example, it's cloud agnostic. It can run on in like AWS. There is AWS service that runs Kubernetes. It's called EKS, I believe. Yeah, first please correct me if I'm mistaken. And on-prem as well, it will work, and it doesn't matter where you run it, it will work the same. Also, it's cheaper because it will make you able to utilize all the computing resources you have. Also, it comes with out of the box auto scaling. If I want to scale my service, if there is a huge traffic and I want to scale it to, for example, 1,000 replica, it will give you that control. If you wanna scale it down when the traffic is going down as well, you can do that. You can make this automatically as well. Also, it comes with simplified deployments. For example, if the current version of the service failed, you can do rollouts. You can do blue-green deployments as well. So Kubernetes is very powerful when you control containers in production. And it's relatively simple as well to run Kubernetes workloads. So now I'm running a Kubernetes cluster on my machine. It's a local cluster. Yeah, it's a local cluster, and it's up and running right now. And the simplest way to run any any service on Kubernetes, we write something called a deployment file, which is you can think of it as a recipe or a description for Kubernetes to that we give this file to Kubernetes, and it will explain to Kubernetes like what we need exactly to do. So here we are telling Kubernetes that we need to create a deployment that's called hello, and it's the containers immediately from this image, which is the image we just created, and expose that container board just like what we did in our Docker file. And we just like we go to the file first, so cd k8, and here we have our deployment file. Then we just like run kubectl apply this deployment file, and now we can see if we run maybe kubegit boots, we can see it's creating our containers, and it's creating 3 because I passed here to the replicas to be 3, and I can actually do this like I just only want one replica, and I can apply it again, and it will terminating like 2 replicas and make only one up and running. So this is Kubernetes when mentioned to cloud native. And yeah, I think I finished. Is there any questions? Can I see the comments from the live stream?
Yeah, I mean, there should be questions coming in the YouTube comment box, but I don't see any over here.
Okay.
But that's okay. I can definitely ask questions. So what Kubernetes distribution are you using to run this Minikube on your laptop?
What Kubernetes distribution?
I mean, how are you running Kubernetes on your laptop?
So I'm using to run Kubernetes on local machine. There is multiple solutions. There is something called K3s, and there is
K3s
something.
by Rancher Labs.
But yeah, Rancher Labs. But I think the most wide used one is called Minikube. I'm using Minikube actually, and let
Okay.
me terminate it now because it will take a lot of resources.
So you're running Minikube and then you're deploying your container as a pod
Yes.
over there. So how, when you do this locally, how much of this can you translate back to when you use it on, let's say, EKS on AWS, for example, right? Is the configuration similar or?
Yeah, it's all the same. It's all the same.
Okay. So that's kind of like the advantage of Kubernetes because you can just run it anywhere and just port it to
Yes.
whatever provider you need to.
Yes.
Okay.
Correct.
Okay. That's pretty useful, especially for folks over here who are thinking of testing this out and then you want to move it to the cloud. How you would want to do it, it's pretty straightforward. It's just template files. It's always YAML. And you could just keep that template file and then take the same thing and then just deploy it in another cluster somewhere else. In AWS.
Also when it comes to Kubernetes, right, there is something, if you open the cloud native landscape, let's say for example I'm running like thousands of containers and I just wanna see more important information or logging, for example, from how the service is our interaction in my cluster. Okay.
Right.
So I go, for example, to the landscape and I check. There is a lot of solutions here. There is so sometimes I spend my time only trying to figure out like what are those services and what they are doing. So one of the things that worth mentioning is something called the service mesh. So if you have like if you have like thousands of containers or like a huge amount of containers and you want to do some fine grain control over like the policies, which service can talk to which service or which traffic can go to which service, all of this kind of stuff, you can do it with this kind of solutions like the service mesh. And I used Istio before, and it provides this kind of functionality.
Okay.
Yeah.
This is useful. So the cloud native interactive landscape is a good way to understand how big the whole CNCF landscape is and what are the different libraries and services available in the whole ecosystem, so that you can then plug and play and use whatever you need to.
Yes.
Let me just quickly plug this link in here so that people can refer to it.
Also, we have here Vault, so we can control secrets. If the service, for example, requires some secrets to be buzzed as an environment variables, we don't want to keep this in our clusters or our nodes exposed. So we use Vault for that, for example, to store the secrets, and it will be somehow injected directly into our services or into our containers as environment variables.
So in this now, when someone comes in for the first time, and most of the crowd over here, they're all beginners or university students, when they come and see an interactive landscape like this, there's a lot of boxes. Is there a beginners or a noob version of this landscape where if someone just wants to say, okay, I want to do Kubernetes for running containers and then use this for service mesh and then use this for secrets, an opinionated way to look at the landscape? Have you come across anything like that?
Actually, no, but I believe the landscape itself is very simple when you can understand it. Like when you can go through all the services and try to understand what this service does and how can I use it. So, for example, let me find Helm. So Helm. Yeah. So for example, this project. This project is under like application definition and image build. So I know this is related to, for example, packages. So I go to Helm and I open their website, and when you go, let me log in later. Okay, when you go to understand like, oh, so what is Helm actually, you can understand like, so it's a tool for managing charts. Then you know you need to go and understand like what are the charts, and you just like
Okay.
step by step
So
you will
you
understand what is Helm. Yeah,
so you're using the landscape tool as a
as
way
my
to just
reference.
jump in and then find out further on what the tool does. Okay. Yeah, makes
Yes,
sense.
yeah.
Makes sense in a way. Although I would still prefer having an opinionated way, because sometimes you just want to get things done quickly. And if I'm getting into this for the first time and I want to know, all right, if I want to use, let's say, a database and a streaming messaging thing, what's the best thing I can just quickly, like connect together and then make it work. But this helps. This totally helps in this case. So to take a step back from all this technicality, I remember when we first met, we had conversations in the beginning, right? Before, I still remember this one question you had asked me in the beginning about why you would want containers, right? And what's the need of having a container? Now, speed up 2 years, and now we are here, and you're talking about containers, talking about
Yeah.
the whole CNCF landscape. So things have happened, things have changed over the last 2 years. Now, if someone over here wants to get onto that journey and wants to learn about this, right? Just walk us through how you started on this and what tools you used or what resources you used to just get into the whole container and Kubernetes space.
Okay, so actually, the first thing I will mention is the Kubernetes space is very huge. It's very complicated. And I'm
Yeah,
saying
we can
that.
see from the landscape itself.
Yeah, it's very complicated. It's very huge, and things are like, there are a lot of things that I still can't understand. But the approach should be same, which is improve step by step. So at first, like I went to Kubernetes to understand what is Kubernetes in the first place. I read the documentation. I understood Kubernetes. I can just like deploy very simple Hello World application there, and it's up and running. Then I will feel like, oh, so I understand what is Kubernetes, and I try to go in the documentation trying to understand more concepts related to Kubernetes. What is a deployment? What is a pod? What's the difference between pod and container? Why I might need to run multiple containers in one pod? What are all of those? And I just like go and try to read the documentation for that, understand what is actually happening. Okay, and later step by step you realize like, oh, this is like just like a very simple stuff, and you move to the more complicated stuff. What is Helm? How can I install charts? How can I do all of this kind of stuff? So step by step, you just like start doing it, and yeah, maybe one day you can talk about it as well and explain it to others. Yeah.
Yeah, good. Thanks for that. Basically, it's a journey in the end. You
Yeah.
have to start from somewhere, and taking it or taking small steps helps, like baby steps. Just take small bite sizes, because there's a lot happening and there's a lot changing also. Usually, what I've noticed is, especially in the Kubernetes space, or if you're from the JavaScript world, you'll know, if you make a list of things you want to learn, and if you revisit that list 6 months later, you'll see a lot of things have actually changed.
Yeah,
So.
correct.
So it's okay to not learn everything, but it'll be much better if you learn the core services, you learn the core concepts first, because the fundamentals usually don't change a lot, and then you can start looking at the tooling, start looking at what works where, what's the flavor of the month, so that you can spend time on it and then switch it again after 1 month. But yeah, I mean that's kind of like how you would want to do it. So we have a question over here. Wait, let me just bring it to the screen. So we have Omar who's asking, what do you think about certifications, CCAD and others? So Osama, you've seen these certs before, right?
Yeah, I know about it. I didn't try to get one actually because me myself, I don't care about certifications that much, because certification is a way to show off that your capabilities. But currently, when I try to apply for like job applications, I feel like certification might help me more to prove that, oh, I can do this. I worked with Kubernetes before, and I
Right.
know this stuff about Kubernetes. So that's the way certification works, right?
Right.
But
Yeah,
I didn't
certainly.
go.
Yeah.
Yeah,
It's a valid point, because a certification should be just seen as a way to validate what you already know.
yeah.
So when an employer looks at the certification, they think, okay, this person has passed a certain exam. I'm assuming that they learned it and then they have the experience, and then you pass the exam, which means that when I ask you certain questions, and I know if I give you XYZ job, you'll be able to do it. Of course, there are ways to get a cert even without studying, right? You could just to pass somehow. But that's like in the smaller group always. So definitely it helps, especially the recent exams that are coming in for any cloud provider, like for AWS, for example, right? We have a lot of certs over there for the certs which are coming in Kubernetes and other spaces where whatever certs are coming. These the questions are not straightforward. They're not questions which you get outside where you can just buy from somewhere and then learn. You actually have to understand the material. You actually have to understand the content and even have the hands-on experience so that you can answer it. So definitely, I think the certs, if you take 2020, for example, I would say, yeah, I mean, hands down, having a cert really helps because it validates what you know. It also helps you in reinforcing what you're learning because you're preparing for the cert yourself. So we have like different folks over here. Let me add Omar into the stream. Omar, you around?
Yes,
Hello.
yes, I am.
Yeah. So Omar, you've done a certification already, right? Not on AWS, but something else.
Yeah, no, I did the AWS machine learning as well.
You've done the AWS machine learning. Yeah, one of the few who's done the AWS ML cert in Malaysia. So, I mean, like Osama mentioned, right? Initially, he thought the certs are more of a way to show off, and now he believes that it makes more sense. What are your thoughts on this?
No, I agree with him. I definitely agree with him because at the end of the day, it just gets you through the door, right? And for employers, I think it adds a level of trust. So yeah, I agree fully with both of you.
My story is a little similar. I can, when Osama said that, I kind of remembered my past. So I've been in this industry for 16 years, and I actually believed that doing a cert is a waste of time because I could see anyone and everyone could do it. It's another story because I come from India, and in India we have a lot of coaching centers where you can actually get trained. So much so that if you go to a specific city called Hyderabad, there's a street called Amirpet. It's very popular. You can just search on it online in Google. The whole street has posters of every technology you know on earth. And there's a guarantee over there that you'll learn everything in 5 days and even pass the exam for a certain amount. So
5 days.
You'll see. Yeah, exactly. Yeah, 5 days. And there are people who have gone there and trained. There are some people who have come out who have done well in the job. There are people who have just done it for the cert. But when I saw all of this, I thought, you know what, this never makes any sense, right? So which is why I never did a cert. In fact, my first technical cert was in 2018, I believe. That's when I actually did it, the first one. And it was cloud related. So that's how I got started with certs also, because I started seeing that in this market right now, when you're talking to people are always looking for credibility, whether you're an employer, whether you're someone who's looking for a consultant, or anybody else, or even if you're just talking to someone on a technical term, right? They want to see whether you are who you think you are, right? Or you are actually credible enough in the tech you're doing. And one of the ways to validate that is a cert. There are other ways to do it for sure, but for folks who don't understand the tech properly, a cert at least gives them a bit of comfort, saying, okay, somebody else has validated this person. So I would suggest to anyone who's tuning in right now, if you are looking at certs and you want to do it, I would suggest definitely, invest some time, but learn properly and have some hands-on experience and do a certification so that it aids you when you're looking for a job or a better opportunity out there. From a cert perspective, we have not planned for a session on certifications, but maybe we can add one later in the upcoming weeks where we can talk about certifications in general and then about the AWS landscape on certs and how it helps you to grow also better from a career perspective. But yeah, that's that. So I am not out of questions. I don't have any for now. Omar, if you have anything for Osama?
No, not really. I enjoyed the talk. We'll go through the slides again. Thank you so much for doing it.
Because we'll have Omar soon talk about machine learning on containers. So.
Machine learning on containers. Okay.
Why not?
Wow.
We'll decide on a date whenever it happens.
Maybe one day can talk about machine learning on Kubernetes.
No, Kubeflow. Actually, Kubeflow. I was playing with Kubeflow. Maybe we can do it some other day.
Yeah, Kubeflow. Yeah, why not? I want one day, one of the days, one of these sessions, we want to do like a joint session. Have two people working on something together, right? And like code sharing and peer sharing and doing it. Okay, so we have at least one person who said that they want to have a session on certs. So perfect. Thank you, Naufal. You validated it, so we are going to definitely plan it out and then do it in the coming weeks. So stay tuned on our Telegram channel and group on when this will happen. I believe there's definitely going to be value in this. Joint session definitely on things like MLOps will really be helpful, but we would need to first cover some machine learning concepts before we jump into MLOps. So we'll try to cover those things in the near future. We are definitely going to bring in folks, or you will see me actually taking some of these sessions, and I'll try to keep it as simple as I can from my end also. So with that, thank you so much, Osama. Thanks for your time and for showing us how you can actually get started on containers. And for folks who are tuning in right now, if you are on the group, you can definitely chat with Osama later, because I believe he's there in the group. If he's not, we'll add him over there directly. And if you have any questions on containers in general, even later, you can definitely reach out to him on the group or separately. He's definitely approachable. And also, if you want to learn something on containers, just take him for Mandi out next time, and he'll definitely show you on that. And on that note, we also have to plan for a Mandi session soon. So thanks, Osama. We'll be closing in soon, so I'll just put you, just stay backstage, and then we'll connect again. Yeah?
Okay.
Thanks. Cool. So
one guy, he asked a question last moment.
All right, so that's on the group. Let me just share the link. Yeah, I have it with me. Here's the link. So Naufal, I've just shared the link in the comment box, so you can just join in over there, and then you can stay connected over there. We have a couple of folks who have been sharing. It's a bit quiet. I guess it's because people are shy. They're not sure what kind of questions are being asked. So please feel free to ask questions on anything about the cloud. Nothing is there's no stupid questions. Let's put it that way. So one of the things we always want from folks when we do the sessions is to get feedback, and the feedback matters. Like you just noticed that taking certain feedback helps us to understand what is the content required, because we are doing this for the community. We want all of you to learn and level up so that you can do better at your jobs and any opportunity which you get out there. So your feedback matters. So please do share your feedback on this form, and put in any feedback you have for us. You want to see what kind of content? Do you think the content is good? Do you want more of the same speaker again? Do you think the speaker should do a better job? Do you think the host should do a better job? So whatever works. You don't want to see me, you want to see somebody else. Yeah, totally. Just put that in the feedback form, and we'll take care of that. So with that, we'll be closing in a little early today because Osama did a pretty awesome job in compressing everything about containers in a very short time. So think about containers being in a compressed form. But yeah, so thank you so much on joining us on a Friday evening. I know Fridays are usually a start of the weekend. People want to do things, but I still see there's a consistent flow of viewers coming in and watching the show. And you can always definitely catch this on YouTube later because the videos are always going to be there. So thanks a lot. Appreciate your time again, and have a safe weekend. And we'll see you next week.